Greetings and welcome everyone. My name is Maka. Welcome to the channel. If you are new to this channel, please subscribe. If you're a returning subscriber, welcome back, welcome back. I know I haven't connected to the agricultural sciences grade 12 for quite some time, but I'm coming back with another lesson. So in this lesson, we're going to look at the digestibility of feeds. One of the most important things that we're going to look at is just basically the concepts, the factors that affect or influence the digestibility of feeds. We're going to look at the methods of improving or rather increasing digestibility of feeds. Then we're going to do a lot of calculations. Hey, we're going to do a lot of practice looking at the previous question papers and just try and calculate the digestibility of feeds. We're also going to look at the quality of feed, that is the biological value of proteins. We're also going to look at the importance of proteins, also look at the energy value of feed, and also the nutritive value of feeds. So basically that's what we're going to touch on. For our practice, we're going to use the answer series, a study guide or questions and answers. So this is based on CAPS. So please, the publication I'm going to use is the 2019 publication. So the questions might be a bit older. I'm not sure if they have a new publication, but please do look it out. Please do check it out. Make sure you buy that that exercise. It's basically just a 2-in-1. So it has questions, then there is the answers as well. So for each topic that you basically do for your grade 12, so you will never go wrong with this. So obviously, because we didn't get consent from the publisher, we will just take a few questions from them. Then we'll also check previous question papers, and yeah, we'll just do the questions together. So please do get that that guide. Please get that study guide. It's quite valuable. It's very useful. The questions there are quite useful. It helps a lot. So yeah, let's get to the video. Let's get to the lesson basically. So now, if we look at the factors that affect digestibility, we've got various factors that affect digestibility. And now these, for example, are composition of feed. Looking at the crude fiber, we've got the composition of the ration. We've got the preparation of feed. So how do you prepare the feed? And also the type of an animal. It's one of the important factors. Which animal are you going is going to utilize this feed, and also the quantity of feed that is being consumed. And also it's very important to look at the age of the plant. How old is this plant? And also to look at the issues of nutritive ratio, feed additives, looking at the water. If you remember in the previous lesson, we talked about dry matter, and also water as one of the most important factors in the feed. We also look at the animal's age as well as the body mass. And what is also important to note is the digestive system of that particular animal. So remember, when we were talking about water on the previous lesson, we mentioned that for this type of an animal, the animal will actually need this quantity of water for a day. This type of animal will need so much liters and all that. So it's the same with feed as well. And also the palatability of feed. How palatable is this feed, as well as the quantity of the feed that is being consumed. So it's one of the important factors. So there are various factors that are important that you need to think. And now with this part, you don't have to memorize. You don't have to memorize these factors, but rather look at the important things that you need to consider when it comes to feed. So the level of feed, that is important. The production as well as the reproduction of that particular the feed itself, and also the type of animal, right? And also the time, which include the season now, and also the climate. And also you look at the issues of temperature and humidity. So in grade 10, you actually looked at the type of felt and how climate actually influences that. So those are very important factors to consider. So you don't have to actually memorize, but just think about all the other factors that you may think of. So have an idea of what is it that we are talking about. What is digestibility? You look at digestibility, right? You try and actually define what digestibility is, right? Then once you are able to define that, it becomes easy now for you to be able to know the factors, right? So basically, if we're looking at digestibility now, this is the difference between the amount of feed that has been ingested, right, by the animal, and the amount of the feces that have been produced, right? So that is the practice, right, of digestibility. So what is it that has been digested by the animal, and what is it that has been taken out? What are the nutrients that have been absorbed now by this animal, right? So we need to be able to calculate now that amount. We need to be able to calculate the digestibility now of an animal. So there are a lot of examples that we need to check out. So the first thing that you need to do, as I mentioned, that be able to define what digestibility is, be able to separate digestibility from the feed, right? Once you are able now once you know what is feed, right, what is digestibility. Now, if we're talking about digestibility, we are talking about now the amount of nutrients that have been absorbed, right? Now, how do you know that? So it's basically the difference now between the feed that has been taken in by the animal, that has been ingested. That is the correct term that we use in agriculture. So this is the feed that has been ingested by this animal, and also the amount now of feces that have been produced. So you calculate the difference now between them. So that is the digestibility of feed in basic terms. So now if you are talking about the factors, you need to be able to actually define that before you can actually think of the factors. I hope that makes sense. So you need to be able to define before you can even talk about factors that affect the digestibility. Obviously, if we're saying it's the nutrients that have been absorbed, that means now the nutritive ratio that we're going to calculate at the end is one of the important things. The water that is taken in is one of the important things. The composition of feed, what is this feed that this animal is taking in? So it's one of the important things, right? The level of the feed, the digestive system again of the animal is one of the important things, because we know if we differentiate between the calf now and also a matured cow, the digestive system is different. So those are the important factors to consider. And also, when it's winter time, and also when it's summertime, the feed will be different, right? And also the different types of felt. We know we have sour felt and sweet felt, and also we have mixed felt. So that is basically also one of the important things. And also the amount of water in this feed, it's one of the important things, right? The temperature, again, plays a huge role. And also the quantity of feed that has been consumed by this animal is very important. So it is important now to actually be able to define what digestibility is. And also, once you're able to define, you then now able to basically explain it in simple terms, so that when a question comes and this question asks you about the factors that influence, you know what is it that we talk about here. We know what digestibility is, so any factor that you can think of, so you don't have to memorize from the textbook. You know, I've been saying this, I don't encourage people memorizing, but I encourage people to know the terms, know the concept, the simple English. Break down the word into two if you have to. Look at the prefix of the word, look at the suffix of the word, and use the English that you know in trying to explain the term without you memorizing what the textbook says. But now, how do we then improve the digestibility, right? So we need to know the type of the crop now this feed has been produced, right? We need to know the stage of the group of the growth at which now this plant was cut when we're making the hay, right? We also need to know the method that was used in making the hay. We also need to know what happened now in the preparation process and the method of feeding. We also need to know in terms of the supplements, the supplementing of the ration, right? What is involved? We look at the amount of protein that is there, the issues of non-protein nitrogen as well, right? Then we also look at the grinding, we look at the crushing, we also look at the milling of these grains, right? We look at the soaking of the grains, we look at the pelleting of the grains, and also we look at the micronizing of and also popping of the grains. So basically, how you improve digestibility, you have now other factors now, right, that you need to look at. What is this hay that we are talking about, right? What is the type of crop that this hay, or rather the feed, has been produced, right? So now you know that basically in agriculture we've got certain terms. So by now, if we are talking about hay, we know that as an agricultural student, we're talking about dry foliage or dry grasses that is used as the animal feed. So this is just an umbrella, right? So now, these are the important things because they matter where in the digestibility of the feed. I hope that makes sense. Now, there is another important concept, right? The digestibility coefficients, right? Let's take an ad break there. I want to drink water, then we're going to continue. My beautiful people, welcome back, welcome back. So, now, let's look at the digestibility coefficient, right? I had a lot of you requesting me to actually do that. So, we're actually gonna do calculations on the digestibility coefficient, right? Just various calculations. It can be one or two. Some, as I have mentioned, that there will be from the answer series, but also some from, let's say, the previous question papers and all. So I just want to come with various calculations, right? So that we can just get used into calculating the digestibility coefficient. But now, before we just jump into calculating, what is this digestibility coefficient that we are talking about? So a coefficient is a constant number or a factor that measures a specified property of a substance, right? So it is basically expressed in a percentage, right? So there are actually different steps in calculating that. So in our case, basically, the digestibility coefficient, we're going to express it in percentages. So this is the percentage of feed that is actually digested, that has been digested, right? So it basically helps the farmer to determine the digestibility of the feed. So if we calculate now the average, so what a farmer will need basically is to calculate the average digestibility coefficient by basically conducting an experiment, right? But now, as I have mentioned, that there are basically different steps in calculating the digestibility coefficient. And also there are quite different steps in interpreting those values. And there are basically different implications of those values, right? But now what you need to make sure before you do that, the feed and the manure, before you calculate, what you need to keep in mind is that these values, the feed and also the manure, remember we said when we're defining digestibility, this is the difference between the feed that has been ingested and also the amount of feces, right? So try by all means to ensure that these values are in kilograms. And also these values refer to the dry matter. So on the previous lesson, we calculated the dry matter, right? So now, for you to calculate the coefficient of digestibility, what you will need to do, basically the formula is the dry matter feed intake, which will be in kilograms, minus, so you are subtracting now the manure, that is the amount of feces that has been taken out now by the animal, right? Then you divide that by the amount of feed that has been taken, then you multiply by 100. But because remember, we said we calculated in percentages, right? Does it make sense? So we actually going to do the calculation. So now, what this coefficient of digestibility tells us is the percentage of food has been absorbed for growth, it has been absorbed for production, it has been absorbed for reproduction, right? And whether the feed or the food is a roughage or is a concentrate, right? Now the concentrate will have high coefficient of digestibility, and also the roughages will actually have a low coefficient of what? Digestibility. Right? Now, think about this for quite some time. Refer to your previous knowledge. What is a roughage? What is a concentrate? Right? Think about it. Think of the pastures of the forages. Think of the hays. Think of the silages, right? So these are roughages. These are feeds that contain high percentage of fiber, right? Whereas when we are talking about concentrates, we are talking about feeds that are rich in energy, right? So these are grains, these are molasses, right? They are energy rich grains. They've got a lot of proteins in them. They've got a lot of vitamins in them. So take time, because we've got different types of feeds, right? So now we're going to do the calculation. Then we're going to proceed to other factors, right? For example, after we have done our calculations, we're gonna do the feed quality. Now let's get to our different examples, right? So let's say our question reads as follows. A heifer was fed with 25 kg feed with a moisture content of 15%. This heifer excreted 8 kgs of dry manure. Now calculate the digestibility coefficient of the feed. So now remember, we said that with the formula, for us to get the digestibility coefficient, we subtract the moisture content from the dry matter intake, right? So this is the dry matter intake, right? This should be in kgs, obviously. Minus the dry matter of the manure, right? Now this will also be in kg. Now remember, we said what we said about the digestibility coefficient, right? Then you divide that by the dry matter intake, what has been ingested now by the animal, right? Then because we need this in percentage, then we're going to multiply it by 100. So obviously this one divide by 1, right? So now we've got the feed of 25 kgs. But here's the trick here. The moisture, this feed has got a moisture content of 15%. So what we need to do first, right? We need to separate now the moisture content. So we have the dry matter of 25 kgs, right? But now this feed has got 15% moisture. So we need to get that 15% moisture, right? So now what do? Then we multiply this by 15, right, over 100, because we are looking for the kgs now from the percentage. Now if you take 15% of 25 kgs, then that will give you what? 3,75 kgs, right? So that is the mass of water. So we separate that now. So what we'll do, the next stage now that we will do, is to separate this dry matter, this moisture content from this dry matter, right? So 25 kgs minus now 3,75 kgs, right? Then what do we get there? We get 21,25 kgs. So this is the dry matter intake now, right? But now we move, because we're still not done, right? We're still not done. So now we still need to calculate the digestibility coefficient. So now we have been given, like we said on our example, this heifer has excreted 8 kgs of manure. So now what do we need to do is to take this 21,25 kgs minus, right, 8 kgs, which is the dry matter manure, right? Now then we divide that by 21,25 kgs multiplied by 100 over 1. Remember I said that this obviously will be over 1, right? Now all right, so what do we get from here now? Right, so we get now 62.35%, or rather you can round that off to 62.4% of digestibility coefficients. Then you are done. You get your 5 marks, right? So let's look at the second example now, right? An animal consumes 24 kg of hay with a moisture content of 12%. It excretes 7.3 kgs of dry manure. Calculate the coefficient of digestibility of this hay. Right. Now, remember we said from our formula, which is basically digestibility coefficient is equal to the dry matter intake minus the dry matter manure divided by the dry matter intake. So this is multiplied by 100 because we need the percentage, right? Now we have been given what the animal has consumed, but this includes the moisture content. So again, what we need to do is to subtract first the 24 kgs, right? We subtract the 12% from the 24 kgs of hay, right? So now what does this mean? This is 24 divided by, multiply by 100 over, multiply by 12 over 100, right? Now let's calculate this. So we've got 12 over 100, that is 0.12%, fine, right? Multiply by 24 kgs, so we've got 2.88 kgs of water. So now because we don't need this water, we're gonna subtract now 24 kgs minus 2.88 of this moisture content, right? So what we have now is 21.12 kgs. So coming back now to the formula, calculating now the digestibility coefficient. So it's 21.12 kgs minus 7.3, right, over 21.12, and we multiply this by 100 because we are looking for a percentage, right? Now so this 21.12 minus 7.3, then we divide that by 21.12 again, and obviously we'll multiply this by 100, and we've got 65.4% of the digestibility coefficient, 65.4. So confirm that with me, right? So let's work out the last example of the digestibility coefficient. Now, here's the question. A total of 2.5 kgs of green lucine with the moisture content of 60% was given to an animal. The animal excreted 0.255 kgs of dry matter in feces. You see the difference here? You are given now, okay, yes, you are given the moisture content and percentages again. Okay, so it's still the same thing, right? So now what do we need to do? We need to separate now. Remember, always work out the dry matter first. So now we have 2.5 kgs of the dry matter, but this dry matter has got 60% of moisture, right? So what do we need to do now? We need to calculate the moisture content, right? So 2.5 by 60 divided by 100, or 0.60, right? So that is 1.5 kgs. Fine, right? So we have now the dry matter of this lucine, right? Then now what we need to do is to subtract the moisture content from the dry matter content, right? So this is 2.5 kgs minus 1.5 kgs. Then what do we get there? Very simple. So we get 1 kg of the lucine, right? So for us now to calculate the digestibility coefficient, then our digestibility coefficient is equal to the dry matter intake minus now the amount now that was excreted in feces, right? Which is the dry matter manure. But for argument's sake, just make sure you write this in full, right? So this is the dry matter that has been excreted in the manure. Then we divide that by the dry matter intake. So always make sure that you write that in full, or have keys for your acronyms if you use acronyms. I'm only using acronyms because I don't have enough space. Fine. Then now we were told, right, that the animal has excreted how many kgs? 0.255. So now we've got 1 kgs minus 0.255 kgs. Then we divide that by 1. Then we multiply that by 100 over 1. And now if we quickly calculate that, 1 minus 0.255, so that is 0.745 multiplied by 100. So we get 74.5%. So always make sure that you put that percentage there, because that is a mark. Now that is a mark again. So usually this counts for 5 marks. So this is also a mark. So for you to work that out again, this is a mark, right? So you need to ensure that you include your formula in full. Do not assume that the examiner knows what you're talking about. If you're going to use the acronyms, make sure that at least you put in some keys, right? Don't assume that the examiner knows what you are calculating. Explain it or calculate it as if you are explaining to a grade 5 learner, just as I do now. And always keep in mind that you need to work out your dry matter first, then your digestibility coefficients should always be in percentage unless you are told otherwise. So always read the question carefully. So these are the only examples I'm going to do for this lesson. However, if you feel that we need to do more examples, then let me know. We'll have a lesson where we just do our calculations. But for now, I think these 3 examples at least give you an idea of what we are talking about. Obviously, on your exam, there will be follow-up questions based on the calculations. So you also need to keep in mind. But for now, I just wanted us to just do the calculations. All right, now let's continue. Let's look at Unit 5, the quality of feeds. So we're going to start with the biological value of proteins. Now, the biological value of proteins can actually be expressed as the proportion protein absorbed from the feed that is incorporated into the proteins of the animals. So now we know, like from basic knowledge, that we need proteins, or the animals need proteins for growth, and they also need proteins for production, right? And when we're looking at the proteins, it's also important to understand that the amino acids are the essential building blocks of the proteins, right? And they can be divided into 2 groups. These are essential and also non-essential amino acids. So we're actually going to look at that a little bit later on. And both these groups are equally important for protein synthesis. So the proteins with a high biological value have a good quality amino acid composition, right? So, okay, fine. We're still gonna get there, right? So the animal can actually produce non-essential amino acids, but it must ingest. That means it must take in the essential amino acids as food protein. So how do we measure now this protein content in the feed? How do we do that? Right? So the quality of protein for single stomach animals can be expressed in a number of ways, right? In different ways. So we would need to look at the biological value, right? So now this is basically the oldest and the most common measurement, right? And also what we may need to know is the essential amino acid index. So this is basically the measure of the quality of protein compared to the protein in the egg, for example, right? Because all these essential amino acids are present in the egg, right? Okay, and also what else we need to know is basically the ideal protein principle. So let's look at the biological value now, right? So what is this biological value? So when you're talking about the biological value of a protein, we basically, so we we express this in percentage. So this is basically the amount that has been absorbed. Now, the amount of what, right, of the nitrogen that basically remains in the animal's body after a protein has been digested, right? So the biological value, I'm going to repeat this again. So the biological value of a protein is the percentage of the absorbed nitrogen that remains in the animal's body after a protein has been digested. So this is the direct measure of the proteins in the feed that the animals utilize to build the body tissue and also to maintain the body processes. Remember, we said the proteins are needed for growth as well as reproduction, right? So now the differences now of these biological values will then depend on various factors. Now, these factors may either be species of the animal, the weight of the animal, or even the age now of the animal, right? But again, the quality of proteins can actually be expressed in different ways. I mentioned earlier that it is expressed in percentages, and when we're talking about it, we are talking about the absorbed nitrogen that the animal's body retains after digesting the protein. So we mentioned that we can actually look at this in different ways, like the essential amino acid index. So now, what is this amino acid index? We said earlier, just now, for example, if we look at, we said this is basically a scientific way of expressing protein in the content of the feed, right? So if we compare the ratio to the amino acid content of a feed of that an egg to that of an egg, right? This egg now will contain, let's say, 10 essential amino acids. That is in a favorable ratio, right? Then the ratio now in which the 10 essential amino acids in a protein occur is then compared to the ratio in which now the 10 amino acids in the egg protein occur. So you will basically need to calculate this, right? You would need to calculate. So for example, if we're looking at the proteins of, let's say, animal origin, right? We've made an example of an egg, but now let's look at the milk, like the milk protein, right? Then we also have fish meal protein, but also with vegetables as well. There are actually various proteins that we can find. For instance, your soybean has proteins, your wheat has proteins, and also the corn has got proteins. So looking at the importance of animal proteins in rations now. So basically, animal proteins supply amino acids to the body for the repair of decomposed tissues and also for building up of the new tissues. And now these proteins are basically required for the production of hormones. They are required for the production of enzymes and also other secretions in the body, right? So now what will happen if there's an excess of protein, right? So now an excess of protein will actually be damaged, after which it serves as an energy source in the form of animal fats, right? So another important thing to note is that the proteins actually serves as building blocks for protein synthesis. So this is also something that you have done in grade 11. Right? So it basically supports the structures in the body. Right? So it's the building blocks of the synthesis of the supporting structures in the body. And also, proteins actually play a vital role in the regulation of the metabolism. Right? Now, let's look at the value of the feed, the energy value of the feed. Right? So the energy basically is measured in kilojoules. Right? We've got different types of energy, from gross energy, digestible energy, metabolic energy, and net energy. But we're gonna explain that. Right. Now, if we're talking about this energy value of the feed, now we've got what we call the nutritive ratio, right? Which is the ratio or the proportion of digestible protein, right, to digestible non-nitrogenous nutrients. So these are carbohydrates and fats, basically in a ration. So it will be expressed as a ratio, right? So the purpose now of the nutritive ratio is to determine the potential of the feed to actually fulfill a certain function. So you'll actually be able to learn later as to how do we then interpret the nutritive ratio to determine whether the ration is the best suited to maintain that particular animal or also for the production. But as I have mentioned, that we have different types of energy, right? Now, these different energies, they actually assist now with maintenance, with production, replenishment of body tissues, development of fetus, physical activities, and so on and so forth, right? And also, the biggest difference again between the ability of feeds to supply for energy also lies in their digestibility, right? Now, looking at these different types of energies, we said we've got 4 of them, right? We've got the gross energy, we've got the digestible energy, we've got the metabolic energy, and then we've got the net energy, right? So now when we're talking about gross energy, we are talking about the potential energy value of the feed. Then with the digestible energy, so now from the gross energy, you actually, for you to get the digestible energy, you actually subtract the energy through that has been lost through what? Excretion, right? So for you to get the digestible energy, so basically the digestible energy of a feed is just the gross energy minus what? The energy that has been lost through the excretion, that is through the feces, right? Then we've got the metabolic energy now. So basically, metabolic energy is just minus now the energy that has been lost through what? The urine and also the fermentation of gases, right? So the end products in ruminants, right? So now, what will happen is, let's say looking at the gross energy, right? Looking at the gross energy, remember we said that the gross energy is the energy basically that has been released when the feed is actually burnt, right? Now, so this is the amount of heat energy that is released now when the feed is burnt to its oxidation products. That is your oxygen or your carbon dioxide, right? Then you move to the next one, which is the digestible now energy. Now, for you to get the digestible energy now, you take that gross energy, then you subtract the feces, right? Then now, so basically the feces, the digestible energy now is just gross energy minus the energy that has been lost in feces, right? Then, so this can be actually, as I have mentioned, that it can, we then move to the metabolic energy, right? So now with metabolic energy, we are saying this is the digestible energy minus the energy that has been lost through what? Urine, through feces, through other end products of digestion, and also through gases, right? Especially in ruminants, right? So now what you will do, it will actually be body heat minus that percentage of the loss. Then now you have got the net energy, right? So now, with net energy now, this is the metabolism, the metabolic energy, right? Minus the energy that has been lost as heat liberated through the digestive and also metabolic processes, as well as chewing, right? So with this energy, what do we mean now? We are saying it's gross energy minus the energy that has been lost in feces, minus the energy that has been lost in urine, in gases, the heat requirements of the animal. So this is basically the energy now that is finally available for what? Production as well as a reproduction. If we look at this diagram, right, this energy flow through a ruminant, so this is basically just the summary of what we are talking about when we're talking about gross energy, digestible energy, metabolic energy, as well as the net energy. But now, if we then calculate this energy, why are we calculating the energy? What is the purpose of calculating the energy, right? So this energy now, when we calculate it actually helps us to determine the diet of the animal. It helps us to determine the standards of feeding and also the formula of the ration, right? So we've got various formulas now that can be used for calculating energy, right? So for example, we said, just in summary, looking at the diagram again, with the digestible energy, we said it's the gross energy minus the energy that has been lost in feces, right? But with the metabolic energy, that is the second formula, right? It's the digestible energy minus now. So you can put in brackets. So you can add these on the side, right? The energy that is lost in feces, the energy that is plus the energy lost in urine, plus the energy loss in gases, right? Then you get the total number. Then with the net energy, right? This is the gross energy minus, right? The energy loss in feces plus the energy loss in urine plus the energy lost in gases plus the energy lost as body heat. So this is basically the overall energy that is used for growth, that is used for maintenance, that is also used for lactation. Briefly, before we end this lesson, let's actually look at the nutritive ratio. So basically, the nutritive ratio of a feed indicates the protein content of a feed. So it's basically expressed as a ratio, as I have mentioned earlier, between the digestible protein content as well as the digestible non-protein content. So for you to determine the nutritive ratio, the formula is basically nutritive ratio is equal to 1:2. So now what you will do is to take the percentage now of digestible non-protein substances and divide them by the percentage of digestible what? Protein. Then you will get that ratio. But now you will have what we call a narrow ratio as well as the wide ratio, right? Now, with these two, right, a narrow ratio is usually between less than 1:6. So usually now this feed is basically has got a highly digestible protein content. But if we get a wide nutritive ratio which is greater than 1:6, now this means that the feed has got low digestible protein content, right? So now a farmer will then use the nutritive ratio to see if they are achieving their what? Goals, right? Then now you will also be required to actually compare between digestible proteins and also non-digestible proteins, depending on what the protein is used for, whether it's for growth, it's for milk production, it's for maintenance, it's for reproduction, it's for fattening. So you also need to be able to tell whether now in this nutritive ratio, in terms of the digestible protein, is there lots of biological value, lots of protein with high biological value, or lots of protein with low biological value, or it has been used for replacement of tissues. So you actually need to be able to determine the function of the digestible protein and also the function of the digestible non-nitrogen substances, which include the proteins, the carbohydrates, and also the fats. So I think let's end this session here for now. Then on the next session, we actually gonna just look at the types of feeds. So I have briefly touched on the differences between roughages and concentrates. So on the next session, we will just compare these two, give characteristics, give the functions, the different types, the examples, and also the uses, and also maybe look at the examples from the previous question papers, and continue with our lessons as we go. Otherwise, that's it from me. If you're still listening up to this far, please don't hesitate to leave a comment in the comment section below, and also please do like the video. Please share the video with other people. Please subscribe if you haven't subscribed for the channel. The positive comments, or rather the comments in general, actually help me to determine, okay, what is it that now I have to improve on, what is it that I need to look at, and also just basic stuff that a lot of individuals may be struggling with. So please take your time, go through the lesson. Yes, I understand it's a long lesson, but just try and practice along. And now remember, this is a week's work in just one lesson. So it's not going to take just one video, or you're not going to understand it just instantly the same time you listen to the video. You might need to repeat the video, let's say 2 times or even 3 times. It's up to you. But yeah, basically just share with me whatever that you think. How is it, what is it that is frustrating you at the moment when it comes to the first sections of the first term? How do you think we can improve in ensuring that we pass this subject with distinction? We ace the subject. So yes, please do connect with me. You can send me an email at loxamaka@gmail.com. Otherwise, thank you so much for your attention. Until next time, love and light.